Thank you, SAE, for giving us this opportunity to talk about this very important innovation which we bring about detecting the refrigerant leak. Refrigerant is very important for cooling system for air conditioners in the automotive systems, and there are numerous technologies. Say, for example, there are three ways for us currently to know about the refrigerant leak. One, when the cooling performance goes down, so the car user goes for checking, then he comes to know about the refrigerant leak. Or in a regular service, we check for refrigerant leak, and then we are able to find out a leak. Or in case of a breakdown, then we come to know of a refrigerant leak. So these are the three major areas where we come to know of the refrigerant leak, and in all these three areas there is leak which has already happened, so we don't predict. Now, do all car leaks? Yes, all car leaks. So leak tide is a relative term, and nothing is actually a leak tide. So there would be a smaller leak to a larger leak or emission which is happening because of the permeation or other stuff. So definitely there is something which is impacting the refrigerant leak all the time. So what is leak? Leak is precisely a hole where the refrigerant pass through, and the flow of the fluid through that leak is something which is called as leakage. So I'm not putting more of emphasis on these terms, but yeah, important for us is to know what are the factors affecting the leak. One is the usage pattern of the car, age of the system, sometimes also the climatic conditions when we are at a topmost condition, when most rigorous condition, which is like high ambient or tough roads and all, and also the product design. So what are the design factors which have been taken for managing the leak tightness of the system. So yes, there are a number of things which impact the overall refrigerant gas leak. Now, what has been done in terms of refrigerant leak management in our industry is, yes, one of the key thing which is done for refrigerant emission reduction is the reduced refrigerant charge. So has been a substantial reduction over a period in the refrigerant charge size in the automotive systems. Leak tight system is also designed. So thanks to the entire industry and SAE, that our systems are very leak tight these days. And then maintaining the system for leaks, there are two things. One is testing for the leak, and second is arresting the leak. So what we are going to focus here is about leak testing. So the idea of us to have this leak testing should be understood in detail, and we should have within the production process and in the service centers or any other area to find out what is the leak which have which will have an impact on the cooling performance in days to come. There are a number of reasons for us for the leak testing: economic, safety, reliability. And let me quickly jump to what is the importance, why we should go for leak testing. So there are one way of detecting leak, as we talked about, is the local detection. So where is the leak? Pinpointing the leak, or it is also called as localization. The other way is overall detection, to come to know whether in this car there is a refrigerant leak or not. It is not about detecting or finding out where is the leak. It is about finding whether there is a leak or not. So that is something which is crucial for us in this technology, because this technology tells us there is a leak in the car or not. If we know there is a leak in the car, then we have so many tools available with us in industry by which we can find out where is the leak. So identifying or isolating a car which has a leak versus which is not having a leak is something which is addressed in this innovation, and that is something which we feel was missing so far in the industry. Second, it is less expensive because it's very quick, easy, hassle-free, quick monitoring tool, can be used in various applications, able to find major as well as minor leak up to 50 grams per year of a leak is something which we have estimated, which we can easily find with this type of technology. And when we are talking of 50 gram per year, we're not talking of any specific point, we are talking of accumulated per car per year. So that means all the leaks put together, if they quantify to be 50 gram per year, yes, we can detect with this technology. And it is also able to estimate a rough calculation about the leak size, that hey, how big or small is the leak. So that is the beauty of this. So if the leakage is like 200 grams per year, which means you're going to face a refrigerant charge size reduction or a cooling performance down in next 1.5 year, then also you can come to know that yes, this is going to impact how quickly, in 1 month time, 2 month time, or 1.5 year time frame or so. Now, how this technology works is very simple. Park your car at the testing station. So we'll be trying to build a small testing station, turn off the engine, wait for a while, and done. It's done. So it's a the amount of time you wait can tell you how smaller the leak or how big the leak is. But yes, it is done. It's very quick, easy, and no work to be done on the car. So how this typically looks, or how this typically works, you can see in the street. The first picture, what it shows is the covering of the car. So what we try to do is to reduce the air movement around the car. So it's not that you need to build a airtight design and bring the car in and then do some very sophisticated any reduction or any ventilation system or a free air movement is something which we need to restrict, so that any air which is near the car remains there, does not get mixed with the outside air. Then we also have a leak sensor which is under the car. Now this under the car leak sensor is something which detects and gives us, so what you see on the right hand side is something which tells you, this is a sensor technology which tells you how much of refrigerant, say 134A or 1234YF, how much ppm is present in air. It can detect even 1 ppm of refrigerant in air. So as we see the rise of this ppm level from 1 to 2 to 5 to 20 to 50, we can estimate what is so the rise of this can actually give us the indication of what type of leak we are working on. So we know refrigerant is heavier than air and it tries to settle down. So that's the property of both these refrigerants, 1234YF as well as 134A. They try to settle down. So what we essentially do is we try to reduce the air movement so that any refrigerant which is leaking out of the system, because imagine the refrigerant gas inside the system is under pressure. Even if the engine is switched off or the AC is not working, still it is under pressure. So any leakage, the gas comes out. As it comes out heavier than air, it tries to comes down. As it comes down, we have a sensor underneath the car and under the cabin which detects and tells it what is the ppm level. So if there is a leak, we are going to sense the refrigerant presence in air. Now, with this presence of refrigerant in air, if we wait for a shorter, slightly more time, we can also see the rise of this ppm level because it's not getting mixed with the outside air. So when we see the rise of this ppm level, the rate of rise also give us the indication of the size or the magnitude of this leak. This is something which is important, and we have tried and tested this technology a number of times. Sometimes for our trials or some areas, we have also done a covering of the car just by kind of providing a bubble wrap around the bottom of the car, and it beautifully works. Now, where this technology can be used, it can be used at your OEM level. At OEM level, when you're making the car and you want to ensure that when a customer experiences the car, he is not finding any refrigerant leak issue. So before dispatch, you can have this system integrated wherein you can find out if there is a leak in the car or not. Rental service providers, when the car is parked, they can check for value-added services like car washes or fueling stations and all. All these places, or even the parking slots, can offer this or a check wherein if the car is parked into that particular slot, yes, it can detect the refrigerant leak as well. And the car service station, for sure, you don't need to open the hood and find out, plug the RRR system to find out there is a leak or not. This can detect from the car very easily whether there is a air conditioning or the refrigerant service required in this car or not. Also, this can be used for logistic centers. This is not for car air conditioning, but for overall automotive. So when a, a goods carrier, a reefer truck is leaving, before it leaves, you know whether there is any refrigerant leak issue, so whether this will be able to complete its journey in good shape for whatever distance it's traveling. So there are a number of applications. It brings a new technology to know whether there is a leak or not in the HVAC and in the mobile air conditioning system of cars and other automotives. So thank you very much for listening to me. If there is any question, please let me know.